So dear friends, as the examinations are drawing near, the students are worried what to prepare, where to start from. So this video would help you that which topics are important, how to prepare them, which topics are to be given more priority. Let's start with the last chapters first because they are more scoring chapters. You require least effort and you would get more output. So first of all, communication systems. So you need to learn what are the elements of a communication system. Modulation, that is why we need to modulate. What is modulation? What is carrier wave? What is a modulating signal? Why can't we transmit a signal directly without modulating it? So what are the requirements of modulation? Then you must learn amplitude modulation especially, and what is modulation index and how to calculate it. Simple calculation, just we have to divide the amplitude of the modulating signal by the amplitude of the carrier wave. Further, you require a block diagram for a modulator which contains amplifier, which contains a baseband filter, and it contains a square law device, and what are the various functions of these blocks drawn by you. Then you need to learn demodulations block diagram, special reference to the rectifier and envelope detector and the corresponding waveforms. Refer to the NCERT book. Better you would be able to draw the diagrams better from NCERT book. Further, you require to derive a relation for range of a transmitter, a simple application of so-called Pythagoras theorem. Then differentiation between ground wave, sky wave, and space communications. So this completes your communication systems. Now let's come to electronic devices. First of all, you would switch over to PN junction. What is the depletion layer? Why is it formed? Further, what happens to it during forward and reverse biasing of a diode? Then you need to learn the circuit diagram for characteristics of a PN junction and the corresponding characteristics in forward as well as in reverse bias. Then applications of diode as half wave, full wave rectifiers, and special reference to Zener diode as a voltage stabilizer or voltage corrector. Further, transistors. In transistor, you must learn the circuit diagram for studying the characteristics of a transistor. Then common emitter amplifier as well as oscillator. So their working circuit diagram as well as input and output waveforms. Lastly, we come to gates. You must know the logics, circuit symbol, and corresponding truth table for all the 5 gates: OR, AND, NOT, NOR, and NAND. Further, you must be able to combine only NAND gates or only NOR gates to get any of the basic gates. That is why NAND and NOR gates are called building blocks. So next topic is atoms and nuclei. So in atoms, you have to just learn the same Bohr's theory as you have already gone through in chemistry also. So Bohr's theory you must learn equations for radius, equation or derivation for velocity of the electron and energy of the electron in nth orbit. Then comes hydrogen spectrum, that is spectral lines, Lyman series, Balmer series, Pastein series, Brackett series, Pfund series, and so on, and their corresponding transition numbers, that is the starting point and the final point, and the base numericals, which may require calculation of wavelength for a particular series of hydrogen spectrum. Further, in nuclei, you must learn binding energy curve. The shape of the binding energy curve must be practiced in written, but that is you must draw. And what is the cause of fission, cause of fusion, and why these two processes liberate nuclear energy. Then comes nuclear decay law. You must learn the derivation or formula N is equal to N naught e power minus lambda t. Then definition of decay constant, what is half-life, what is its relation with decay constant, and the corresponding numericals. Dual nature of matter and radiation, it contains only two topics. One is photoelectricity, photoelectric effect. So you must go through Einstein's equation. H nu is equal to work function plus kinetic energy. Further, you must be able to write and derive equations for kinetic energy, cutoff voltage, and work function, both in terms of frequency as well as wavelength. Then there are four graphs, one between kinetic energy and frequency, between cutoff voltage and frequency, two graphs for V and I for constant frequency and another for constant intensity. And the second part is matter waves or de Broglie waves. Here you must learn the four relations for de Broglie wavelength, that is lambda is equal to h by mv equal to h upon root of 2m into kinetic energy, h by momentum, and lastly h upon square root of 2m q into v, where v stands for accelerating voltage. Then there is Davison and Germer's experiment. Sometimes experimental setup is only asked in the exam. Then you must learn the graphs corresponding to Davison and Germer's experiment. These graphs are specially drawn in terms of another system of coordinates, that is polar coordinates. And lastly, you must be able to learn the calculations which confirms that de Broglie wavelength and the wavelength obtained using Bragg's law happen to be same. So experimental setup is required, graphs are required, and corresponding outcome of the experiment is required, plates of a capacitor. So next chapter is current electricity. In current electricity, you must learn the relation, derivation for drift velocity related to electric field and to the current. Further, we come across Ohm's law, and you must be able to solve the questions on series and parallel combinations of resistances. Then another important topic is internal resistance of a cell. Three equations based on internal resistance: V equal to E minus IR, I equal to E upon R plus small r, and lastly small r equal to E by V minus 1 whole into capital R. And there is a graph between potential difference and the current drawn from the cell, and what are the corresponding factors which you can draw from the graph, that is internal resistance, EMF of the cell, maximum current from the cell. So cell combinations in series and in parallel are to be solved. That is, what happens to the EMF and internal resistance when cells are combined in series combination and in parallel combination. Then very important part, Kirchhoff's laws and its application to various numericals as well as to meter bridge. So Wheatstone bridge is another important part, and last part is potentiometer and its applications. Applications are, first of all, how to compare EMFs of two cells, and second application is internal resistance of a cell. So you must go through all of them, try the circuit diagrams in written, and at least mathematical steps you must write. Magnetic effects of current and magnetism, very important chapter. So first of all, Biot-Savart's law and its applications to circular current carrying loop, its magnetic field at the center and at an axial point. Then Ampere's circuital law, it has got of course some poor weightage, mostly doesn't come in the exam, but sometimes it may appear in the form of 2 or 3 marks question. So how to apply Ampere's circuital law to a straight current carrying wire, how to get the magnetic field due to that. Of course, solenoid and toroid, they are not in syllabus, so you can easily skip the topic, safely skip the topic for CBSE exam, but do prepare for school exam. Then very important part is motion of a charged particle in magnetic field. So how does it behave when it is moving parallel to the field, at right angle to the field, at acute angle with the field? So when angle is right angle, it would describe a circle. You learn the derivation for radius of the circle, angular velocity of the charged particle, time period, and its frequency, which all apply to very important topic, 5 marks question, cyclotron. So its construction, working, principle, and limitations are must be learned. Another important part is force on a current carrying conductor in a magnetic field, which further adds to force between two parallel current carrying conductors. Another important question. Force between two parallel current carrying conductors further finishes into definition of 1 ampere, a usual question in the board exams worth 3 marks. Okay. Lastly, when you go for moving coil galvanometer, again you need what is the principle, what is construction and working, and there is another topic at the end, that is how to convert a galvanometer into voltmeter or ammeter. There could be a numerical based on that. So moving coil galvanometer could also comprise one more 5 marks question. Second part of the chapter is magnetism. In magnetism, you must learn Earth's magnetism, that is definitions of dip, declination, and horizontal component. And second part is para, dia, and ferromagnetic substances. How do they behave in magnetic field? What is the effect of temperature on them? What are their relative permeabilities, susceptibility, etc. And what is their internal structure? So this second part of course may have only question of 1 to 2 marks. Sometimes there is no question at all. So first part, that is magnetic effects of current, is more important. Let's switch over to fourth unit, that is EMI and AC. Easy as well as easy to understand and important also. So first of all, derivation of Faraday's law. When a U-shaped conductor has a straight rod in contact with it and the rod is moved in magnetic field, what is the magnitude of the EMF induced? There is a solved question in NCERT which shows what are the nature of the graphs obtained for the force experienced by the conductor, induced EMF strength, and current going through the circuit, and lastly what is the power required to pull the rod. So these 4 graphs are important. There is a solved question in NCERT, must be gone through. Further, eddy currents and their applications, simple concept, no numerical, no formula. Then self and mutual inductance and how to derive the relation. There is one more question again solved in NCERT. When you place two circular connecting loops, one is large in size, another is very small in size, at the center of the bigger, then what is the mutual induction for this pair of the two rings? And most important topic in the chapter is transformer. So one small question, why is AC transmitted at high voltage? This could be 1 mark question. And then what is the principle, construction, working of transformer, and what are the various losses due to the transformation. Further, you must learn the diagram as well as principle, construction, working of AC generator. Now let us come to alternating currents. First of all, you must learn what is the behavior of pure inductor, pure capacitor, and pure resistance in AC. Their variations in resistance and reactance with frequency. What is the phase difference between current and voltage? So this video is already on my YouTube channel. You can go through for LCR in AC as separate and series LCR circuit. This video is already in line with my other videos. So series LCR circuit is most important, and what is the condition for resonance? You must learn this part well. So let us switch over to next topic. So average power you must go through. It is a small derivation. Usually in books, derivation is completely given for a general phase difference between current and voltage, that is phi. Voltage is usually written as E naught sine omega t and current as I naught sine omega t plus minus phi. But usually question in the exam is either you derive a relation for capacitor or for a resistance. So accordingly adjust the value of phi. For a resistance phi would be equal to 0, and for inductor or capacitor phi is 90 degree plus or minus. Okay, next is electromagnetic waves. So again very simple chapter. So first is failure of Ampere's circuital law and how was it modified by Maxwell. So this is there could be a short question of 2 marks. And electromagnetic spectrum, that is a sequence of all the waves in the electromagnetic spectrum. Which one is highest in frequency, lowest in frequency. So you must learn the order of their wavelength at least. So it has to be prepared one day before the exam so that you are able to retain it. In case frequency order is asked in the exam, just divide c, that is velocity of light, by the corresponding wavelength. You would get the order of the frequency also, and the corresponding uses in each case. So these are the only two parts in electromagnetic waves. So easy chapter, and you must go through some simple questions. One is why are X-ray telescopes placed at the satellites? What is nuclear winter? What is the role of role of ozone layer for human survival? These are very simple questions. So these concepts must be learned. Okay, so let's come to the last part, that is optics. In optics, the ray optical part is same as in your class 10th, that is lenses, mirrors, prism, etc. So spherical mirrors, that is concave and convex mirror, how is image formed, derivation of mirror formula, proving focal length is equal to r by 2. These are simple derivations. Then we have very important topic, total internal reflection. Lots of questions most of the times, and its applications. What is the phenomenon? When does it occur? Then we have total reflecting prisms, which are right angle prisms, their ray diagrams. Then optical fibers, and usually there is a question of on value based part from this part. Then we come to refraction at spherical surfaces, that is convex and concave surfaces, and on combining the two such refractions we can switch over to lens maker's formula, and there would be corresponding numericals also, changing of the refractive index outside the lens medium. The refractive index outside may be larger than the lens, then how does it behave, and so on. So one simple question, usually if a convex lens made up of some refractive index, say glass, is placed in medium 1, medium 2, medium 3, draw the corresponding rays if the refractive index of the surrounding medium is lesser than the lens, equal to the lens, then greater than that of the lens. Further, scattering is another important issue. Why is sky blue in color? Called Rayleigh scattering, in which intensity of the scattered light is inversely proportional to fourth power of the wavelength. Why is sun red in color at the morning and sunset time? Why is fog white in color? And so on. Then derive prism formula, that is mu is equal to sine of a plus delta m by 2 upon sine of a by 2, the graph between angle of deviation and angle of incidence. Then in wave optics, lesser important is Huygens principle and its applications. Most important, interference, Young's double slit experiment, derivation for fringe width, and the factors affecting it. Diffraction is another part, but less important as compared to interference. And polarization is another simple and most important part. So there is usually a question when two polarides are placed at right angle to each other, then another polaroid is placed in between them at certain angle theta, then what is the resulting intensity at the exit point if unpolarized light is incident on the first polaroid. So these are simple questions based on it. So optics is easier but longer. So but it can be easily prepared because ray optics is already in your so-called 10th class was also there. And last part to add is You must learn ray diagrams of telescopes, microscopes, and their corresponding magnifying power. So thank you for listening. I hope it would help you a lot. So best wishes for your outstanding performance. Please do like my video, share it, and subscribe my channel for future updates. Thank you.